Swayam Prabha. Digital India. Educated India.
Hello everyone. So, we will start today the new module that is textiles for human protection from mechanical threats. In the last session, we have discussed the protection from water pollution, different types of water pollution removal methods we have discussed, and how textile can help in protecting us from water pollution. Those details we have discussed. Now, in this segment mechanical protection, there are different types of threads we will discuss, and the mechanism of the threads and how they are actually prevented by the textile material, how textile materials are used and their evolution of the protective textiles, and different standards we will discuss, and different case studies we will discuss for different types of threads. So, if we see the mechanical protection, the threads are of different types. So, the different types of threads you can see here. So, if we see the spectrum of dangers from the mechanical threads are basically, one is ballistic threads, that is very common protection against projectile. So, if there is any like bullet, shrapnel, if this type of threads are there, and that thread is classified as ballistic thread. And then cut actually the resistance to sharp objects like knives, glasses, industrial blades, that is the cut. And stab is entirely different from the ballistic and cut, because this is defense against pointed object designed to penetrate, okay, like ice picks, daggers. So, these are meant for the stabbing this thing. So, we need to protect ourselves from any injury from stab. And the fourth one is the slash. The slash is actually a combination, basically combination of different types of threads, like protection from broad cutting motion. This includes the stab and cut. So, very sharp, very fast cutting motion is there, which is known as the slash type of thread, like sharp edges, machetes. So, all these things are there, that we will discuss each and every threads separately. So, the textile materials or the protective textiles for ballistic may not be useful for cut, and the particular fiber which may be good for stab protection, but may not be optimum for the cut protection. So, all these issues we will discuss, their mechanisms, mechanics, everything we will discuss, different relationship, energy relationship or force relationship, balance relationship we will discuss in this segment. So, apart from this mechanical thread, there are different other threads like thermal thread we have already discussed in our previous course part 1. Radiation, UV radiation we have discussed, and here chemical and biological protection we will cover in this segment, and electrical, from electrical threat this may not be that much critical, because if we can insulate, ourselves, so that we can protect us from the electrical threat. Now, let us try to see in brief the history of the protective textiles, how this protective textiles evolved. So, in early days human used to protect himself from the animal using the animal skin, raw animal skins were used to protect from the any mechanical threat, like even layers of fabrics. So, multi-layer fabrics were wrapped to protect from any type of mechanical threat. Then preliminary armors were used for protection in warfare and manual labor. So, this type of protective measures were used in the early form, early age. Then due to industrial revolution, the different types of fibers were evolved. So, introduction of tougher natural fibers were there. So, like flax and different cotton and all this silk, they are the fibers which are weaker, but tougher natural fibers were used, even regenerated fibers were developed, and also the basic weaving techniques were there for workwear. So, like plain weave or some twill weave we use with the tougher natural fibers. So, that is the second stage of evolution. Then in the next, in 20th century, the synthetic fiber came. So, it was developed, synthetic fibers were developed which are stronger than the natural fiber, like nylon, polyester. They were actually, they offer improved strength and also durability, because natural fibers they have main problem with the durability, because they are biodegradable, they are affected easily by the environment. So, the invention of nylon and polyester helped in improving the strength and also durability. And in late 20th century and still at present, so what there are different types of high performance fibers were actually invented. So, this revolutionary advancement of high performance fiber like ultra high molecular weight polyethylene and different types of other aramid, para-aramid, okay, smart textiles were used, and different types of structures were used, and lightweight, the protective textiles were evolved which are flexible. So, this if we use this high performance fibers like aramid and ultra high molecular weight polyethylene. So, this type of fibers are lighter, and so that those leads to development of lighter material, lighter this protective textiles. So, which are very essential for the comfort and performance. Now, if we try to see the classification of protective capabilities from mechanical threats, So, protective textiles are categorized based on the primary hazard they are designed to mitigate. So, that is there are different types of hazards and we use protective textiles for different types of threats, primary hazards. So, based on that there are these protective textiles are classified depending on their capabilities, and this classification helps selecting the appropriate material for given applications. Like where our threats are low, so we will select a particular class of protective textiles, and where the expected threats are high, in that case we will select different classes of protective textile. Now, see our classification of protective textiles are based on the different types of threads. As we have already mentioned, the mechanical threads are of broadly 4 different types. Accordingly, we select our textile material on the basis of the threads perception. If we expect the threads, mechanical threads would be like a projectile, then we use ballistic resistant fabric. If it is cut type thread there, suppose in the industry people are working, in those applications we use clothing protective textile which is cut resistant fabrics, made of cut resistant fabric. So, this ballistic or cut they are entirely different. Okay. Similarly, stab proof vest we use where we expect there is a threat from the stab, or slash proof garment, slash resistant slash proof garment. So, this is where we are expecting any threat from the slash. So, depending on our threat, so we classify our protective textiles from mechanical threads. First, let us try to see the protective textiles for ballistic protection. So, where all this type of thread, their mechanisms are different. So, we must understand the mechanisms of all these types of threads, how they actually damage. So, in ballistic protection the typical mechanism is that involves multiple layer, because the velocity of the projectile is very high. So, in that case to stop the bullet or the particle, okay, large particle or fragment, we need multiple layer of high strength fiber. So, this if you see there are multiple layers of high strength fiber fabrics are there. These are used to dissipate the energy. See here if we use the multiple layer, so when it penetrates, bullet penetrates, okay, or any fragment penetrates, flying object penetrates, that single layer cannot handle. Okay. So, we need multiple layers, so that the energy of this flying object gets actually dissipated in through the multiple layers. So, the mechanism we will discuss in detail. So, this it dissipates the energy of the projectile and there will be deformation. So, that this textile, multilayer textile, after this bullet hit the surface, it will deform by extending this fibrous structure or extension of the fabric, and which actually absorb the majority of the this energy from this flying object, and then as it is deforming, during deformation it absorbs the energy. So, that it will prevent from penetration. So, we need the fibers to be deformed, and the multilayer will absorb the majority of the load. So, deformation here it is very important to absorb the majority of the energy, that is the, and here the materials are para-aramid basically, that is a Kevlar, Twaron, okay. And another material which is very popular, ultra high molecular weight polyethylene, okay, like Dyneema, Spectra, these are the commercially available fibers. So, these are the fiber, they make the material multilayer, it is a little bit stretchable, flexible. So, when the bullet hits, any flying object hits, they deform and then absorb the energy. And in place, if we use the solid material, metallic metal or maybe ceramic which does not deform. So, that is also used, that is for the hard body armor, that we will discuss separately, but their mechanism will be different. But protective textile if we use, this is by deformation, this absorption of the energy is by deformation. So, the main applications are body armor here. So, vest, helmets we use, vehicle armor and protective linings. Next is the cut, stab, slash resistant textiles. So, we will discuss individually separately the cut, stab, slash resistant textiles, but because their mechanisms are entirely different. We need different types of textile structures. So, that we will discuss, but here in general the mechanisms are, these are achieved through dense weave. The basic requirement is that we have to get the fabric which is dense and it is made of inherently cut resistant fiber. It should not be the fiber which cuts easily like cotton, we cannot use, but if at all if we use, try to use, in earlier days we used to use, but their dense weave has to be there. So, that it does not the sharp object, it does not touch our skin. So, we use both combination like dense weave with made from the high cut resistant textiles. So, fibers that we use in the combination which resist shearing or piercing action of sharp object. So, shearing action basically the cut takes place or slash takes place due to the shearing action, and piercing basically is controlled by the dense weave, that is a stab type of threads, and the shearing action is basically here it is due to the inherently cut resistant fibers. So, these combinations are important depending on our application or requirement we use. We may not need always the dense weave. So, that all these aspects we will discuss in detail. The key materials here: high performance polyethylene, aramid fibers, we use stainless steel, glass, even different types of composite yarns we use, but here if you see steel, stainless steel, glass, if you see the this comfort characteristics, it does not give the good tactile feel. So, these fibers, steel or glass fibers, and that is we can develop some yarn, composite yarn, where glass or stainless steel will be in the core and it will be covered by say high performance polyethylene for giving better comfort. So, all combinations we can make. So, this also we will discuss in detail, the yarn structure, the fabric structures, everything we will discuss subsequently. And the applications of this cut slash tab resistant textiles are protective gloves, very commonly used, arm guard, security uniform for slash tab resistance, industrial aprons are used for accidental injury, to prevent from accidental injury, and athletic wear in different types of athletic. So, we actually we may face some sharp object. So, for those type of like fencing. So, this type of sports we use some stab or cut protective textiles. So, we can classify this material based on the protective capabilities. So, let us see the capability of protection time, this is an example, and what are the material used. So, ballistic is the type of protection we need. So, the examples are bulletproof vest, helmets, where there may be chance of the projectile come. So, that for that those applications we use ballistic type of protection. And here aramid fiber like Kevlar and ultra high molecular weight polyethylene, these fibers are very commonly used nowadays for bulletproof. Okay. Next is the cut, stab, slash protective textiles. The main applications are gloves, sleeves, aprons. So, in the sleeves also we use cut protective or slash protective textiles. So, steel core yarn or glass core yarn we can use. Hybrid yarns are normally used in this type of applications. In bulletproof we do not use typically the hybrid type of textile material, but in cut slash stab we use the materials which are hybrid, that hybrid yarn, core sheath type yarn we use. And other type of protection that we have already discussed, like thermal or flame protection, like firefighter suit, welding gear. So, there we use the material which are inherently fire resistant, like Onomax, PBI, like Metaramid, PBI, modacrylic blends we use. And then threads are of chemical, biological thread that we will discuss in the subsequently, it is a subsequent module. Okay, the different types of lab coats and all this there, where the threads are there from chemical and biological attack. So, PTFE laminated textile material are activated carbon. So, they are used in this type of threads. So, and radiation protective X-ray, nuclear suit, different types of radiation. So, lead embedded or boron fibers are used. So, there are, apart from this there are different types of protection requirement. So, different types of fibers are used. Now, our prime discussion would be in the mechanical type of thread in this module. Now, emerging trades, that is smart textiles. So, here integration of sensors and electronics are required. So, which will actually monitor in real time about the wearer's health and environmental condition. So, in the protective textile like in bulletproof vest, we can incorporate this type of smart sensors which will monitor the soldiers or police personnel's health and what are the environmental condition, that through the electronic sensors we can get. And another direction is that it should be comfortable, ergonomically it should be comfortable. So, we need to reduce the mass of the that is our protective equipments and it should be flexible. So, there are lots of research going on to develop the materials that offer high protection, but reduced bulk and improved comfort. Although there is a trade off. If we want to improve the protection levels, that means we need to have higher weight, thicker material. So, that will give higher protection, but at the same time it will reduce the comfort, and that type of trade off we should address, because that is why different types of materials are developed, like to be developed, which will create the comfortable protective textiles. And also the work, there are different universities, they are working, different laboratories they are working on multi-thread protection, like they will mitigate the multiple hazard at a time, okay, like cut with a flame. So, and also chemical resistance. So, this type of threat can happen in any environment, like industrial environment, like flame, cut and mechanical chemical resistance, even from gaseous, say protection from gases, toxic gases, from the noise. So, different types of multiple threats are there. So, that in that direction we should work to develop our protective textiles. And nowadays the sustainable protective textile. So, either we should go for eco-friendly material, we should use eco-friendly manufacturing process, or we should have recyclable material. So, if not 100%, few proportion, some portion of the material should be recycled. So, we can recycle the used protective textile and again blend with the virgin fibers to get the recyclable protective textiles. Now, ergonomics, as I have mentioned, in a protective textiles, if we want to increase the level of protection, it will actually be heavy, multi-layer, and it will not be flexible. So, that it will restrict the body movement and ultimately comfort. So, now what is ergonomics in textile design? So, we have to design our protective textile so that our body movement should not be, it is not restricted. So, scientific discipline concerning with the understanding of interaction of among the human and other equipment. So, that is other elements which we are using here, it is protective textile, personal protective equipment, okay, that we are using, and how our human body we are interacting, that is ergonomics, that we are trying, we should give focus in this area. Otherwise, designing a fully protective textiles without considering the ergonomics is not going to help. It will be useless, because the wearer will not use it properly. So, in textiles, designing material and garment to optimize human well-being and overall system performance. So, we have to design the material in such a fashion, design the protective garment in such a fashion, it will not restrict the body movement first, it will not restrict the heat transmission, moisture vapor transmission, it should not accumulate the moisture in the microclimate, and at the same time it should not compromise with the protection level, and overall performance level will be enhanced. Overall performance level means the protection performance as well as the performance of the human being due to the comfort and ergonomics. So, focus on comfort, safety, efficiency and productivity of the wearer should be kept in mind. So, safety should be there, and along with the safety, so safety is the first priority, along with that comfort should be there, and if comfort and ergonomics is provided, then efficiency will automatically come, and then subsequently the productivity of the wearer will improve. And next is that why the ergonomic matters, that we have already mentioned earlier. So, beyond the protection, okay. So, only protection, mere protection ensuring users acceptance and effectiveness, that is very important. So, only protection is not going to help. The wearer should actually, the user should accept that protective textiles. If the protective textiles is not comfortable, he will not accept. So, mere protection is not going to help. So, the mobility should be there, it should be breathable and weight distribution. Mobility, that means the ergonomic, it should not restrict the body movement, it should allow the moisture vapor to pass through, and keeping the protection level optimum, the weight should be, the mass of the protective textile should be low. So, that was the basic requirement. Now, what is mobility? Why is it important? So, the wearer should perform the task, all the tasks without any restrictions. Okay. So, it should ensure the free movement of the body part to perform the tasks, and if the body movement is not restricted, that means it will reduce the fatigue, it will prevent the fatigue, okay, and muscle strain will be reduced. Consideration of joint articulation and range of motion. That in the designing we should consider that how much body movement the wearer will make during its performance. If that type of during that range of motion there should not be any restriction. And the breathability, if we see, the breathability and thermal management is also they are also very important. So, there should not be any heat stress, the heat accumulation should not be there. That means, the whatever body heat generated during activity, the clothing should be able to dissipate and which will maintain the thermal comfort. Then the moisture management should be there, that is sweat or moisture vapor, and which will reduce the suffocation, chafing and discomfort. So, that is important. And these are key to better performance in various environment. So, that is, so if it is hot, whether it is hot or cold, depending on the environment. So, we have to select the proper clothing arrangement for proper moisture breathability and thermal management, that we have to see. And then the weight distribution, the weight should be as low as possible. So, if the protective textiles, in spite of higher protection level, if the weight is very high, so it will create this physiological load and fatigue. So, our idea for the protective textile is to reduce the minimize the physiological load, and the automatically the fatigue will be reduced. So, strategic design to distribute garment weight evenly across the body. So, that is important. So, the garment weight should be evenly distributed across the body strategically. We have to design like where the threads are maximum, like in front, like a bulletproof vest. So, we can have the garment designed where we can add additional weight when it is required. Otherwise, in normal case, so that replaceable, removable that panel we can add. So, this when the thread is maximum, so we can add certain garment. So, and depending on the thread, so we can distribute the weight accordingly. And impact on posture and long term wearability. So, that is all important. So, that long term wearability we need the lighter weight. Even someone is standing continuously, for that we have to he cannot carry heavy weight for long time. So, depending on the wearability, so we can select the weight. So, the human factors engineering basically in personal protective equipment. What are the human factors? Like applying knowledge about the human capabilities and limitation to design the equipment, system and tasks. So, that human factors we have to see. So, we must understand the what is the capability of a person and what are the limitations. So, in that case, if we know, then only we should design our equipment. Suppose a person cannot bend, that is a maximum certain level, he can carry that load, maximum that load comfortably. So, all this type of study we must know, we must carry out, because before we designing the equipment and particularly and also the tasks. So, human capability has to be understood first, then in PPE ensuring that protective garments are not just protective, but also it is intuitive and easy to use, fit for human interaction. So, all these things, only protection we should not keep in mind. The key aspects of personal protective equipments are fit and size. So, the fit and size are important. So, accommodating diverse body type. So, that is very important. If it is very tight, then this ergonomically it is not comfortable. Even if it is oversized, then also it will restrict the body movement, and also unnecessary it will add the weight. Donning and doffing. So, during the activity a person should wear quickly, and also when it is not required, he can take off this PPE quickly. So, that designing should be that he can do easily and at a higher speed. So, interface design. So, how the PPE interacts with other equipment, that is also important, like helmets, respirators and the users sensors, vision, hearing. So, that is also important in designing factor. So, the designing of the PPE like mask. So, that we should not, it should not prevent any that the breathing, like the vision, it should not cover our eyes or ear. So, proper designing of the PP is important here. Cognitive load. So, minimize the mental effort to use or manage the PP. So, that is important also. So, if the cognitive load is high, so the performance will be slower. So, mental effort should not be there. That means, if this PP, so that with the after wearing the PP, that person should not think that this how much protection level it is. That should not be in mental, psychologically the person should be comfortable. So, proper test standard the person should know, so that the psychological load is reduced. So, as we are discussing that there are trade-offs. So, the inevitable trade-offs are they like your protection versus comfort. So, if we need higher protection, we have to compromise certain level of comfort, and vice versa. If we need comfort, like making the fabric open for better moisture heat transmission, in that case we will have to compromise the protection. So, as we have discussed that both the things are very important. We cannot have 100% protection by compromising the comfort, that is not possible. So, both the type of this trade off, both the protection and comfort are important. So, understanding the challenge, what are these challenges? So, high levels of protection often come with the increased material thickness. So, if the material thickness is low and here one material is say number of layers we have increasing and we are trying to develop this type of protection for say ballistic protection or any mechanical threat, cut protection. So, this is A with a lower number of layers, B is with the higher number of layers. B will definitely be giving higher protection level, but the main problem is that if we are increasing the layers, that means the thickness is increasing, its stiffness is increasing and also the weight is increasing. So, that will give the lower comfort and that is thickness is increasing, weight is increasing, reduce the breathability, that is moisture vapor transmission will be reduced as the number of layers are reduced and also mobility will reduce because of the higher stiffness. So, that is the trade off. So, we have to understand this challenge first. Okay. Now, let us try to see the different types of common trade offs, like thick material. As I have already mentioned, thick material offer cut or puncture resistance, but they reduces the dexterity and breathability. So, it is basically it will not conform to our body shape and shear resistance will increase and the very stiff, it will be very stiff. So, our body movement will be restricted, okay? And also the breathability, that like your moisture vapor transmission will be, the water transmission will be restricted. So, we are getting after using thick material we are getting the higher protection, like impermeable membrane we can, impermeable barriers we can use, say for protective textile like for the chemical and biological protection. If we use the impermeable membrane, like this is the impermeable membrane is placed on say textile material, this is textile layer, red color textile layer and over that we are using impermeable membrane. For chemical and biological protection we may sometime need the impermeable membrane, but the main problem will be that it will trap the moisture vapor, will not get transmitted. So, what to do? We have to create very fine nano level this barriers, nano level pores, so that it allows the moisture vapor, but is not allowing the biological or chemical agent. But if it is not possible at all, like we need impermeable and that traps heat and moisture we know, but the wearer will not use, cannot use for long time. So, that trade off is important, understanding that trade off is very important. We must understand that what to do for which one is important. So, chemical and biological threat is there. So, in that case this type of problem will be there. So, that the one way is to redesign the garment. So, designing will be important where we have to use impermeable membrane. So, rigid components sometime use like hard body armor, like bulletproof vest we need some rigid component. So, it offers impact protection, but restrict movement. So, we will use this type of plate, the rigid plate, when it is required. So, that is, and it will not be throughout the body, for a particular vulnerable parts of the body it will cover. So, that chest, okay, belly, this type of portion. So, it is covered, and rest of the body part are not covered by this. So, that the it is semi flexible, it is not completely rigid, but obviously it restrict the movement. So, that study we have to carry out, ergonomic study we must do, but we cannot altogether eliminate this protection. Protection has to be there, but we have to optimize the ergonomics or breathability, heat and moisture transmission, body movement, this we have to study, and then that is why we have to formulate some strategy to do all these things. What are the strategies? So, what we can do, smart materials we can select, and smartly we can use layering, like it may not be a single hard part, it may be some scales type structure like fish scale, pangolin scales are there. So, this type of scale structures can be created by a solid hard particle. So, that the overall it will be flexible, like fish scale, it is a flexible, but made of hard cells. So, this type of smart materials can be created, and smart layering can be done. So, targeted reinforcement rather than full body reinforcement, as I have already mentioned. So, reinforcement, that the rigid part should not cover the whole body. Okay. So, targeted, that wherever this is there is a threat, that portion we cover with this protection, rigid protection, so that the body movement is not restricted completely. And also I have mentioned that ventilation system can be created. If we have to provide the impermeable barrier, okay. So, there it is if it is must, if it is we cannot avoid this impermeable barrier, in that case we must create some ventilation in the system. So, that the moisture vapor or heat trapped inside can pass through. So, advanced patterning and ergonomic design is important. So, we should have this type of strategies, and also the goal is that finding the optimal balance of specific tasks and environments. So, that is the final goal, and with a better comfort. So, let us see few ergonomic success and failures in protective textiles. So, the success of the ergonomic successes are, so modular layering system for adaptable thermal protective textiles. So, that modular layering systems are created depending on the thermal level. So, what we use, so if there is a higher threat we add certain layer, when the threat is not there we just remove that layer. So, that is a modular layering system is adopted. Stretch fabric integration into workwear and which enhance the mobility. So, in the workwear, suppose in a case of say any cut protective textile in workwear. So, if we use the stretchable fabric, so that will not restrict the body movement. So, mobility is not getting restricted. So, it improved ventilation systems in firefighting suit, which will reduce the heat state. So, in firefighting if we can introduce some improved ventilation system, so that heat stress moisture vapor transmission will not be restricted. So, the key takeaways are that how attention to ergonomic improve the safety. So, to improve the safety we have to keep in mind the ergonomics, then the compliance will be there and performance will be there. He can perform well, and the use of the protective equipment will be as per the guidelines, the compliance will be there without sacrificing the protection, and the ergonomic failures are there like heavy non breathable suits are that hazmat suits leading to heat stroke. So, that type of heavy fabric and non breathable fabric which creates the heat generation within the body heat does not go out. So, that leads to heat stroke. So, poorly fitting gloves causing dexterity loss and increase accident. So, if the gloves protective gloves like cut protective gloves are not fitted properly, that means it will restrict the body movement, and that accident will increase. So, all these things we have to keep in mind in these failure examples. So, bulky gears or turnout gears hindering the emergency response mobility. So, if it is bulky and one has to respond quickly in case of emergency, that will be restricted. So, mobility will be restricted. So, ultimate the performance will not be there. So, the lesson here, consequence of neglecting the human effort. So, human factors we should not neglect, and that way all these accidents where the protective textiles are supposed to do perform its duty. So, all these things will be, if we neglect this that means that will result this different types of failures. So, the future trends in ergonomic protective textiles are smart textiles with integrated sensors for real time physiological monitoring. So, that textile that it will tell the temperature, humidity level. So, that physiological monitoring will be there. Adaptive materials can be used that respond to the environmental change, like your phase change materials. So, as we have already discussed, phase change materials can be used. Personalized or customized PPE. So, 3D printed or body scanning can be used, the systems can be used to have some personalized. So, different human they have the body features are different. So, if we use the 3D printing or body scanning system, then the PPE can be personalized for their respective body shape, and so that we can design the ergonomically comfortable protective textiles, sustainable and environmental friendly ergonomic solutions to be focused. So, we have discussed the basics of mechanical protective textiles and their ergonomic aspects. So, we will stop here, and in the next session we will start with one of the important mechanical threads, which is ballistic threads. So, ballistic protection we will discuss. Till then, thank you.